Okay, this is page 3 of the review for test 2. And in number 10, we are asked to solve exponential equations. So first you want to see if you can get the bases to be equal on either side. And you can see we can do that in this particular equation. So 1 over 27 is just 3 to the minus 3 power, because 3 cubed is 27. And if you take the reciprocal of that, that's how we get the negative here. And so on the right side, we have 3 to the x. Now that the bases match on either side of the equation, we can just say that, well, x must equal negative 3. Okay. Now let's say you don't see that. There's another way to solve this. It's a little bit more involved, but you can get the same answer. And that is just to take the natural log of both sides. You could also take the common log of both sides, either one. I typically do the natural log because I could just write 2 letters instead of 3. So I'm taking the natural log of 1 over 27, and that's the natural log of 3 to the x. And then you can use the property that your exponent can become out front. So this becomes natural log of 1 over 27 is equal to x times the natural log of 3. And then you want to isolate x, so you can divide both sides by the natural log of 3. And so you get, this is 1, so you get x is equal to the natural log of 1 over 27 divided by the natural log of 3. And so using your calculator, you would just take the natural log of 1 divided by 27, and then you would divide that by the natural log of 3, and you can see you get negative 3. So this is obviously the quicker way of doing it, but like I said, if you don't see that you can write 1 over 27 as 3 to the negative 3, you can always use this method here. So the next one, same thing. 343 is 7 cubed, and so the bases match, so you can see x equals 3. Or again, you can use this method, take the natural log of both sides. And the x comes out front. And you divide both sides by the natural log of 7. And so you get x is equal to, this goes away, x is equal to the natural log of 343 divided by the natural log of 7. And again, we say the natural log of 343 divided by the natural log of 7 is 3. Okay, here we're asked now, these were exponential equations. Now we're asked to solve logarithmic equations. And the trick to doing these is to write this log equation in exponential form. So the base here is 10, right? And remember, logs are exponents and the base is on the bottom. Those are the 2 phrases you want to tell yourself when you're converting a log equation into exponential form. So the base is on the bottom, so that's 10. The log is the exponent, so that's 5.7. And what's left is 2x. Now that you've written in exponential form, you can just divide both sides by 2. And so you get the x, which is equal to 10 to the power of 5.7 over 2. So we're going to have 10 to the power of 5.7. And then we're going to divide that by 2. So we get 250,000, 593. And it doesn't say how to round it, but I'm just going to round it to hundreds place, so 0.62. Okay, Same thing here. The base is 10 in both cases. Now notice we have two logs. So in this particular problem, we only had one log to deal with, but when you have two logs to deal with, the first thing you need to do is combine them into one log. And you can only do that if the bases match, which they do here. So I'm going to bring this log over to the other side, and that becomes log. I'm going to subtract this from both sides. So log base 10 of x cubed minus 2 log base 10 of x. I've subtracted it from this side. And when I subtract it from this side, this just goes away. So that becomes 3. Now I combine the logs into one log. So this becomes the exponent on x squared, and then because it's minus, it's going to be in the denominator. So this becomes log base 10 of x cubed minus, or divided by x squared, x cubed divided by x squared. And that's equal to our 3. I forgot no, that's right. Okay. So now we can just simplify this. So we get log x cubed divided by x squared is just log of x, and base 10 is equal to 3. So now when you put this in exponential form, the base is on the bottom, the log is the exponent, so there's my exponent, and then what's left is x. So x is 10 cubed, or 1,000. Okay. Now with these, you're going to use your calculator regression function. So here, now this is a typo, by the way. That should be a times b to the x. So we're going to go ahead and use exponential regression. So let me go ahead and clear out everything. I always like to do that just to make sure that yeah, okay. So everything's cleared for my calculator. I'm going to hit the stat button, enter for edit, and I have my list 1, or x values are 2, 4, 6, and 8. Just hit the number, press enter. Now I'm going to go to the next column here. This is list 2. These are my y values. So I have 8.7. I'm going to enter that. 43.3, enter. 216.5, enter. And finally, 1082.5, enter. Now that I've entered in my data, I'm going to go back to stat, but this time instead of editing, I'm going to calculate. And this model that we're looking at is exponential, so I'm going to go and find the exponential regression calculator. And so I'm scrolling down, and there it is, EXP-REG. That's exponential regression. I select enter, and now I want to calculate my model. So I scroll down to calculate, and then I press enter again. And there it gives me A and B. And like I said, the worksheet had a typo on there. So this is A times B to the power of X, where A is 1.74 and B is 2.23 if I round it to hundredths place. So my model is Y equals 1.74B to the 2.23. There's my exponential model for this data. Okay, now in the next problem, 13, we are doing regression again, but this time we are doing a logistic function, okay, to do the regression for a logistic function. So I'm going to go ahead and clear everything out and start with this stat here. I'm going to edit my lists. So I have 3, enter 6, enter 9, enter 12, enter 15, enter 18, enter. So I've got my X values. Now I'm going to go ahead and do the Y values. 37, enter. 205, enter. 820, enter. 1620, 29, enter. 1946, enter. And finally, 2011, enter. Okay, but I made a mistake. Sorry, I overlapped. I forgot to switch my columns, so I wasn't paying attention. Sorry about that. Let's start over. I got to redo this. I just kept, let's see here. That's unfortunate. Let me just start over. Okay. Stat, edit, 3, 6, 9, 12, 15, 18. And then we have 37. Oh, wait, I almost did it again. No, yeah, 37. Now we're doing list 2. 205, 820, 1629, 1946, and 2011. Okay, there we go. Sorry about that. Nice thing about videos, you can just skip over all of that. I'm not going to take the time to edit it. You're just going to have to skip. But anyway, now that we've entered our data, this time we're going to press stat again, and this time we're not going to do exponential regression. We're going to do logistics. So you're going to go down your list here and you're going to find logistic. And there it is, logistics. So you press enter when you've got to 8 and calculate. And now it takes a little while for it to do that. So it gives you A, B, and C. And the logistic model, it gives you the equation up here. It's y equals C divided by 1 plus A e to the minus bx. And we're given that A equals 324.88. B is, I'm going to round it, so it's 0.60 if you round it to the hundredths place, and 2024.27. So those are your constants. And if you want to go ahead and plug them in, your model is y equals 2024.27 divided by 1 plus 324.88 e to the minus 0.6x.